Multi-threading in Python. Today we'll talk about threads and multi-threading. We'll take an example. We'll talk about functions and thread objects and functions and discuss some other classes in the threading module. A thread is the smallest unit of execution. It is a part of a process and can be scheduled for execution. It can be executed independently of other code. A thread has a thread control block. This has a thread identifier, stack pointer, program counter, thread state, thread register set, and a parent process pointer. Multi-threading is the ability of a process to execute multiple threads in parallel. Each thread holds its own register set and local variables, and all threads share global variables and the program code. It looks as if multiple threads are running simultaneously, but it isn't. This illusion is created with the help of context switching. A thread's state is saved and another's is loaded during an interrupt. This can improve computation speed on multiprocessor systems. However, multi-threading may also introduce issues of deadlocks and starvation. For implementing multi-threading using Python, we have two modules, thread and threading. Thread was renamed to _thread in Python 3.x for backward compatibility. In this lecture, we focus on the threading module. This observes an object-oriented approach. Let's take an example. Let's import threading. Now double is a function that doubles a number, and triple is a function that triples a number. Declare a function that creates two threads, starts them, and then joins them. By joining, we mean we stop the execution of the current program until a thread is complete. So this function waits for T1 to complete and then waits for T2 to complete. And then it executes the statements after. Making a call to demo prints 7 into 2 is 14, 7 into 3 is 21, finished. The threading module has many functions. Active count returns the number of thread objects that are alive or active right now. Current thread gives us the current thread object. GetIdent gets us the identity of the current thread, and enumerate lists out all alive threads. Main thread gives us the main thread object. Normally, this is the thread which starts the interpreter. setTrace and setProfile set trace and profile functions for all threads, and stack size informs us about the size of the thread stack when creating new threads. The threading module has the class thread. There are many functions we can call on a thread. Start to start its activity. Run represents its activity. Join waits until it terminates and blocks the calling thread. Name, getName, and setName give us the name of the thread and help us get and set it. Ident identifies it. IsAlive tells us whether the thread is alive. And daemon is daemon and setDaemon get and set the daemon. A daemon runs as a background process. The threading module has many other classes. Lock for synchronization. rlock is a reentrant lock. We can acquire and release locks. Condition for condition variables. These are associated with locks. Semaphores help synchronize. They manage internal counters which can never go below 0. Events help with communication between threads. A thread waits for another that signals an event. Timer helps set timers to execute actions that should execute only after a certain amount of time has passed. And barriers help synchronize by using a fixed number of threads that must wait for each other. And that's multi-threading for you. Let's get our hands on the threading module in the practice session.